So here's our negative side of the battery, a positive side of the battery, and we have our full voltage here. Our current flows this way, right? So if we were talking about electrons, our electrons would flow towards positive, but current is opposite of that. So current flows this way. And then we have this device, which we'll say is a light bulb, and that light bulb has a resistance. So we treat the light bulb as a resistor. Okay, so what is a resistor? This is the symbol of a resistor here, and we can, if you look at a resistor, it has these stripes on it, and the first stripe, this right here, usually you can tell the first stripe because you'll have like a silver or a gold color down here. It's always silver or gold, so you know that's the tolerance. So you want to start here. This is our first digit, which is red, and so if I look over here for red, I find that's a 2. So this one, I'd start with 2, and my second digit would be green. So green is 5. So far I have 2, 5, and then I have a multiplier, which is orange, which is 3. So I'm going to have 2, 5, 2, 5, and then I have the multiplier is 3, so I'm going to add 3 zeros. And then I'm not going to worry about the tolerance. So but it tells me here that silver is 10%. So that tells me in this for 25,000 ohms that my tolerance is going to be plus or minus 10%. So that tells me that my resistor is going to have a resistance of 25,000 ohms plus or minus 2,500 ohms. And now a lot of times you'll see a resistor, it'll just say 25K for this resistor, and that means 25, K is 1,000, and the ohms aren't written down, but it's implied. So in series, what does series mean? And let's just look back for a second at this circuit right here. So this is a series circuit, and what series means is that there's only one path for the current to flow. It has to go through each of these elements to get back to the battery, versus a parallel circuit. So let's just talk about just for a series circuit now. In order to calculate the equivalent resistance, I add up the resistors. And the reason I'm talking about equivalent resistance is because it's easy to calculate the voltage or the current knowing the equivalent resistance of my circuit. So a lot of times what we'll have is we'll have a battery, and I'll have a resistor, a resistor, a resistor, and I come back. And I want to know what the current is flowing through given this voltage. I want to know what the current is flowing through this. And so in order to know that, I need to know the equivalent resistance. So I want to write this as just with one resistor. So I want this to represent these 3 resistors. So the way I do that is I can say this is R1, this is R2, and this is R3, and I can just add up the resistance for each of these to find the equivalent resistance. So this would be R equivalent. And then I can use Ohm's law to calculate what my current is. For the parallel, it's a little bit different, and I'll talk about that. I'll come back to this equation. Now let's see. So for circuit elements in series, I know we just said that my series for the set of resistors, I can add up the resistances, and the same is true of the voltage. So if I look back at my circuit here, I can add up. So when I go across, I can add these 2 resistances together to get the equivalent resistance. But I can also add up the voltage. So here I lost more voltage across here, so I would say 7 volts, and then I lose 5 more volts going across here. So I can add up 7 volts that I lose here and 5 volts that I lose here, and that's equal to the 12 volts that was in my battery. So the voltages add for a series circuit. And here we have a series circuit. So these 2 represent the same thing. I'm representing my bulbs as resistors, which they are. And if I want to find the current, I can have an equivalent resistance. So I would add these 3 resistance values up to get my equivalent resistance. And so let's talk about parallel for a minute. So this is an example of a parallel circuit. And you can see I have multiple paths for the current to flow. My current could flow this way through this one, my current could flow this way through this one, or my current could flow this way through this one. And so you can see the difference. Here, a series circuit, my current only has one path. A parallel circuit, my my current can go in multiple paths. So that's how you tell the difference between a series circuit and a parallel circuit. In order to calculate the resistance, so the equivalent resistance, I calculate that differently. So let's just go back. So my resistance here, I figure that out by saying 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So here, if I wanted to calculate my resistance, I would have to use that formula, the 1 over R1 plus 1 over R2 plus 1 over R3, and we'll find that the equivalent resistance is always going to be less than any one of these resistors. So here I have that the equivalent resistance would be more than any one of these resistors. It would be 3 times, if these were all equal, it would be 3 times the resistance. Here, if all of these resistors were equal, then this would be 1/3 of their resistance. So my resistance is much lower in a parallel circuit than it is in a series circuit. And so these are the equations for to use Ohm's law for a parallel circuit. I can see here that my current, my total current is equal to I1 plus I2. So if I think about that, here I need to add up the current that goes through each one of these to find the total current. So I would add them up and find the current here. Here, my current has to be the same all the way through. So the current here equals the current here equals the current here. Whereas here, the current here is whatever the relationship of Ohm's law would tell us. And this is a different current, and this is a different current. But they all have to add back up when I get to here. My voltages are the same. And let's see if that makes sense. If I go back to my, if I think here, my voltage drop, I have a voltage drop across here, a voltage drop across here, and a voltage drop across here to get to 0. But here it's a little bit different. I have a voltage here, and all of the voltage has to drop across here. So I go from, say this was 1.5 volts. I drop 1.5 volts all the way to here because I have to go, this is 1.5 and this has to be 0. So I drop the whole voltage here. Same thing here. I drop all of the voltage here. Same thing here. I drop all the voltage. So the voltage for each one of these resistors is equal. And so that's where this comes from. And this was, we were just talking about, this is called the loop rule when we add our currents up. So if this is my total current going in to any of these three, then I'm going to have a current I1 across R1, a current I2 across I2, and a current I3 across I3. So here at this point, my current is going to be I2 plus I3. Here at this point, at B, I'm going to have I is equal to I1 plus I2 plus I3. Whereas here, my current is just a, this represents the equivalent resistance of these. So these are added together. 1 over R1 plus 1 over R2 plus 1 over R3 is equal to 1 over R equivalent. So it's one thing to think about is it's a good check that if I'm in a parallel circuit, my equivalent resistance should be less than any one of my resistors. And if you don't have that, then you know you've done something wrong when you're calculating resistance. Okay, so here, to determine the equivalent resistance of the circuit and the voltage across each resistor, we'll do this example in class. And then we're going to do the same thing here. We'll rank the bulbs 1 through 6 in order of descending brightness. And when you think about brightness, the brightness doesn't just depend on the resistance. It actually depends on the power. So in order to determine the brightness, we need to calculate the power, which is V times I, or I squared R, or V squared over R. So whatever values we decide to figure out for these bulbs, we'll use to determine which we think is would be to rank them in order of descending brightness. And then these are going to be some more problems that we do in class. And then we're going to do an exploration of physics activity and some group problems.